We've looked before at using formulas. Before, we were evaluating formulas, or what we called algebraic expressions. We were evaluating them by replacing the letters with numbers, and then evaluating that newly created arithmetic expression in order to get a value for the formula. This happens to be a formula that you might encounter in a physics class. It's talking about a gas in a container, and the P is talking about the pressure of that gas, the V is the volume, and the T is the temperature. And the K represents a constant that relates them all. Well, on occasions, we have to take a formula in a particular form and put it into a different form. Sometimes we want to take a formula and solve it for one specific variable. We want to get one variable completely isolated by itself with a coefficient of positive 1. Let's take, for instance, this formula. Let's suppose we wanted to solve this formula for t. We want to isolate t. We want to get the t completely by itself. Well, this is not a linear equation in one variable, but our procedure that we've used to solve linear equations in one variable can be slightly modified to incorporate handling this type of solving a formula for a specific variable. If I want to get a coefficient of 1 on a variable, don't I divide by whatever the coefficient is there already? That's what we do when we're solving linear equations in one variable. Well, for the time being, I could kind of consider this k to be the coefficient on the variable t. If I divided that side of the equation by k, the k's would cancel to positive 1, leaving me t, which is what I wanted to do. I wanted to solve for t. I wanted to get t by itself. Well, in solving equations, no matter what kind of equation it is, if you divide one side of the equation by a quantity, you have to divide the other side by that same quantity to keep the equation in balance. Well, I can't do any divisions there because I don't know what p, v, and k equal. So I simply have to express that that's what I would want to do. When someone tells me what value to put in for the pressure, P, what value to put in for the volume, V, and what value to put in for that constant, K, I can then figure out the temperature. And I would do that by taking the pressure times the volume and dividing by that constant K. So this is our formula after we have solved it for t. We've isolated that particular variable. And I did pretty much the same thing I would do if I had a linear equation in one variable, even though that's truly not what this is. So we're going to look at several other examples of formulas and taking the formulas and solving them for one particular variable. And we'll use very much our approach that we've used in solving linear equations in one variable.